All right, guys, I've got 3 examples for you here, and this is using trig ratios to solve for the values in right triangles. And so let's look at our first one. Part of the strategy of this is seeing what information you actually have. And so when I look at this, I have obviously the 2 legs. So to solve for C, you could obviously use the Pythagorean theorem. I am going to show you a different way to do it in just a minute. But first, let's find some of these angles. Okay, so when I'm solving for angle A, right here, what is actually going to be happening here? I have the opposite and the adjacent for angle A. So immediately I'm thinking tangent. So let's set this up. The tangent of A is equal to 2.73 over 3.41. Okay? Remember, guys, this is a decimal. Okay? So when that's a decimal, what do? Well, we have the tangent. So we want to use inverse trig ratios, inverse tangent of our decimal. And I'm going to keep it precise by plugging in the actual values here. Okay, so when I do tangent -1, or inverse tangent, as we would call it, I'm going to get that A is equal to 38.7 degrees. So let's fill that information in here. And in order to find B, I'm going to say angle B is 90 minus 38.7 is equal to 51.3 degrees. So that's 51.3 degrees. Now, guys, here comes the fun part. Because I have a couple of different ways to solve this. And like I said, I'm not going to use Pythagorean theorem. You could, but I'm not going to. I'm going to show you a different way. The sine of A. Let's think of the sine of A. Well, that's sine of 38.7 is equal to the opposite over the hypotenuse. Notice, I have one unknown. This is good for us because if we have one unknown, we can solve for that unknown. I'm going to take it out of the denominator first. So I have C times sine 38.7 is equal to 2.73. I'll divide by the sine of 38.7 because remember, this is just a decimal here. I'll divide by that on both sides. And I've got C is equal to, 4.37. And if we do the Pythagorean theorem to check, we get the same result. Okay, so that's one way. That's when they give us just straight up the sides and the angles. Another way that they could do it is they could say, here, take this thing that's divided, it's in a circle. You'll probably see one like this on a test. Oops, maybe I shouldn't have said that. And so what we've got here is a 35-degree angle. They gave us that. And so I'm looking here at the opposite and the hypotenuse. And remember, we're taking this as a whole unit, so this is going to actually be x plus 18. And I'm going to set this up. Opposite and hypotenuse. Makes me think sine. Makes me happy. And the opposite over the hypotenuse is going to be 18 over x plus 18. Now we're going to start doing some canceling. Here's how we do it. I'm going to multiply both sides by x plus 18. Okay, so I've got x plus 18 times sine 35 is equal to 18. Well, what happens when I do this here? Okay, before I distribute, I'm going to remember that this sign is just a decimal. So I'm going to divide by sine 35. So I end up with x plus 18 is equal to 18 divided by the sine of 35. Okay, guys? Now, what do I get when I do that? X plus 18 is equal to about 31.38. So I'm going to subtract 18 from both sides. I've got x is equal to about 13.38 or 13.4. Okay, so you see how that works. I've got one more example for you. And once again, remember, you can pause and rewind at any point. We're going to solve for two missing values in this one. In order to do that, I'm going to remember a couple of different things. They've already given me another couple pieces of information. Here's one of them. This is 32 here, and this is x here. So I need to solve for x and h. Well, let's look. I'm dealing with two triangles. I've got the big daddy here, and I've got the little guy here. Notice, this 32 has an opposite, and it has an adjacent, this bottom piece here, okay? This 54 has an opposite and an adjacent, x. So opposite and adjacent, I'm thinking tangent. Preliminary, let's do tangent 54. Why am I doing it up here? Because we're going to see very quickly that this involves two variables. So the tangent of 54 is h over x, which is opposite over adjacent. I want to solve for one of those variables so I can substitute later. I'm going to multiply by x. So I come up with h is equal to x times tangent 54. Hold on to this, guys. Hold on to it. Let's move to the bigger triangle. The tangent of 32 is equal to h over 32 plus x. Watch how beautiful this is when this is in motion. I'm going to multiply by 32 plus x because I'm going to start solving here. So 32 plus x. Watch what happens. 32 plus x times tangent of 32 is equal to h. Wow. If you haven't noticed yet, I have two things that are equal to h. The transitive property of equality says if two things are equal to the same thing, we can set them equal to one another. So because both of these are equal to h, I'm going to set them equal to each other. So x times tangent of 54 is equal to 32 plus x times the tangent of 54. Sorry, 32. Okay? I'm going to get distributive with it. X tangent 54 is equal to 32 tangent 32 plus x tangent 32. Okay? It's looking complicated, but don't be afraid. I assure you, we're not going to be afraid here. Because look at what's happening here. I'm going to set this equal to a number. So I'm going to get my x terms all together. Look where I'm at. I know that 32, tangent of 32, is a number. It's a decimal. So that's good. I've got all my x on one side and a decimal on the other. So look at what happens. I'm going to have x tangent 54 minus x tangent 32. I'm going to factor out an x. So I've got x times tangent 54 minus tangent 32 is equal to 32 tangent 32. Do you see the trick? Do you see it coming? Okay? I'm going to divide by this. Divide by. Okay? I'm dividing by the number part to get x equals some decimal value. When I put this into my calculator, I'm putting this in parentheses down here. Dividing 32 times tangent 32 by tangent of 54 minus tangent 32. I get about 42 feet. Okay? Did that have a lot of steps? Yes. There were multiple substitutions? Yes. Will we go over it in class tomorrow? Absolutely. We'll see you in class.